Welcome to the 8th Science Industry Roundtable organized by EuLA, the European Lime Association. As you know, this is a cycle of 5 sessions aiming at preparing ourselves to the discussions of the national annexes of the new Eurocode 6. An introduction session on the future of masonry and the new Eurocodes took place in December last year. It is followed by 3 special sessions on targeted technical topics. A final session will be organized to conclude on how to translate this into the national annexes. We really hoped that this final session could take place with physical presence in late spring this year, likewise our traditional roundtables. We will discuss how to adapt to the current sanitary context in the next days and will let you know about format and date within the coming days by email. Today is the 3rd special session on execution and quality control. The session will be guided by Professor Miguel AZENHA from the Minho University. As usual, please introduce your questions in the YouTube channel. In order to do that, remember that you have to be logged on in YouTube. I'm now looking forward to today's discussion and hand now over to Miguel AZENHA.
Okay. Thank you, Ulrike, for this introduction. I'm really glad to be here. Good morning to all the participants. It's a pleasure to be here moderating this session. And I thank particularly EuLA for the organization of all this block of sessions and the invitation to moderate. This is a session on execution and quality control that is surely going to be very interesting and covering a very interesting ground for the upcoming discussion. So today we have 3 distinguished invited presenters, and I'll just describe them briefly. First, we have Andrew Smith, who is currently the head of materials development at Forterra, with an extensive career in this context. He's also the chairman of the European Standards Technical Committee TC 125 for masonry. Then we will have Franz, LODERER, who has been in the application research and building physics departments of Xella since 2004, even though he's working on this industry and this field for more than 25 years now. Since October 2016, he is heading the application research and building physics department in Xella. And finally, we will have a presentation by Udo MEYER, who holds a PhD awarded by Aachen University and has been working on Ziegel, the Federal Association of the German brick and tile industry, for more than 25 years, where he's currently the technical director. So we have a lot of experience here on ground. So I'll start with Andy. So Andy, the floor is yours. You may start your presentation, please. Thank you.
Okay. Can we see my screen yet?
Not full screen yet, so you would need to place in full screen.
Okay, how's this? Can you get the share screen?
Yes, it's sharing now. Just switch to full screen mode. You have to press F5 or go to the bottom. Yeah.
It's not showing on F5 for me.
Yeah, pressing there should be enough. Yeah, perfect. Thank you.
Brilliant. Apologies for the slight delay. So good morning, ladies and gentlemen, and it's my pleasure to sort of open up this session on technical science. What I will say, though, is that I'm going to open this up and actually start off and try and put this today's presentations in some form of context. It's very easy for us to dive straight into the very fine detail. But I think when we're discussing the context of Eurocodes, and particularly Eurocode 6 for masonry, it's important to understand the general purpose of what it's all about. And this will feed through to why the aspects of execution and quality control are so important. So let's go back to basics. What are the Eurocodes? What are they all about? Well, ultimately, we need product standards, we need test method standards, and we need Eurocodes. And principally, this is because we need a way of an agreed language to set out parameters, to characterize, to give us properties of the materials that we're going to be using. And these need to be unambiguous. They need to be transparent communications between the producer of the product and the end user. And the Eurocodes are principally designed around providing guidance with regards to the end user of the product, i.e. the construction sector. We as producers, we spend an awful lot of time in the realms of product standards and test methods, because that's what our business is about. But ultimately, our construction products are only a small component, or hopefully a large component, within the general built environment. So that's why it's very important to actually understand, and basically we need to know that there is a communication link between the producer and the end user, such that there is an understanding throughout. So as I alluded to, those of us that are in the construction products arena in terms of producers, we spend a lot of our time testing, as well as the production side of things. And that's important because we want to be able to provide a masonry product that is placed on the market, and we can declare what those properties are. So what we would call the declaration of performance. But that means that we have to provide things like testing methods, the record, providing assurance that the quality of the products is what they are and what we're claiming them to be. This is slightly different when we come into the realms of the built environment and how our products are used. And basically, what we're looking for in this context is we're looking at some form of standardization, or at least an agreement with regards to the process of construction. And this is where the Eurocodes do come in. So if we're trying to standardize the construction process, then the obvious way to go is the way we've gone in much of our production facilities, is to automate. But whilst robotics and systems are in place, they haven't quite yet made it from what I would call the factory-made masonry applications. They haven't made it out into the big, wide, real world where it rains. Well, certainly in the UK, it rains very regularly, or occasionally, as today, we have a nice spring day, but the temperature overnight was very cold. So automation, robotics is only part of the answer. And whilst there are systems out there, we haven't really got there yet with regards to how we use these systems in order to facilitate the standardization of the construction process. So with that in mind, we have to use what's known as the human interface, and that is the construction labor force. And this is important because they are sentile beings, our construction sector workforce, and they think for themselves and they do things. Whilst we can provide them with instructions, sometimes they don't follow those instructions, and therefore what we need to do is we need to make our construction materials and the process of construction as simple and, as I said before, unambiguous type of instructions as possible. So what do we need to do? Well, in essence, we need to define the task. So I use the picture on the right here as just an example, okay? So if we define the task of build a masonry wall using clay bricks and mortar, potentially this is what you could get. Okay, we wouldn't call that regular brickwork in any way, shape or form, but it delivers what we asked as far as the task is concerned, which was to build a masonry wall using the two components provided. What we haven't done is we haven't defined what the expected outcomes are. And this is really where the interface between the outcomes that we desire and the methodologies we use to construct come together. And this really is a way of sort of having some form of control over the execution of the building process, and then ensuring that we have the quality assurance, the quality control, which is embedded within that. So what we fundamentally need to do is we need to define the process of building. And we need to, as I say, make this as unambiguous as possible. So we have that now. Rather than standards, we have codes of practice, we have guidance notes, and for example, with mortars, let's say we have options available to the end user to either have a designed mortar, i.e. on a performance characteristic, or a prescribed mortar, which is more of a recipe approach. So as far as execution is concerned, basically it's the guidance, it's the setting out of expectations. So specifically with regards to the execution side of things, EN 1996 Part 2, and the national annexes thereof, basically this is the fundamental Eurocode 6 for masonry. And within that, the design of masonry structures, it covers Part 2 covers the design considerations, selection of materials, and the execution of the masonry. So this is really guidance to those who are going to use our products of how to use them properly. So it's a very important document from as far as we're concerned as masonry material producers, and it's potentially the last bit of guidance, short of company-based guidance, that we would give to any construction firm with regards to the way that they use our products. In addition to that, we also have national standards or national documents, which fall under the category of national non-contradictory complementary documents. So in the UK, for example, we have a British standard, which is British Standard 8000 Part 3, which is workmanship on building sites, and one of our old standards, BS 5628 Part 3, which is the Code of Practice for the Use of Masonry, now superseded obviously by Eurocodes. But in addition to that, we also have sectoral guidance documents or pseudo standards. So for example, within the context of house building or domestic dwelling building, we have the National House Building Council's standards, which is essentially, it's a manual very similar to a European standard, but it lays out both the context of what the standards for the product should be and how they should be used. So there's a lot of guidance out there with regards to how we can execute construction, in particular use of masonry, as well as obviously concrete and other structural materials. But that leads us into the subtle nuances of individual parts of Europe that have slightly different approaches to this. So I just used two examples here where certainly in the UK we have the human interface element of it is still somewhat to be desired in terms of total quality on building sites. And that arises to problems coming from protection for the weather during the build process and also jointing. Now, for a lot of Europe, I know the jointing process is something, you have a construction process where basically the masonry units are bonded together, and then subsequently there's a specific specialist contractor that comes on and finishes off and does the pointing of the joints. In the UK, that is done simultaneously by the mason or the bricklayer, and that can result in a number of issues, particularly in these days where we're using very lean mortars. And what I mean by lean mortars is very low cement binder contents for masonry construction, where the actual pointing of the joint is very important in terms of the overall longevity and durability of that masonry structure being created. Going back to the first one, protection from the weather, then essentially the issues there that we find is that if during the winter periods, particularly when the temperature is hovering at or about 0 Celsius, so there's a potential for frost in the overnight periods, then that can subsequently lead to damage of wet mortar during the initial curing and setting phases that it goes through once the mortar has been laid and the masonry units are being built up. So it's very important to protect that. But even today, I can show you probably at least half, if not more than half, of the building sites in the UK, particularly the domestic building sites, that do not protect their brickwork at the end of the building day. They will leave them open to the environment. So therefore, if it's windy, if it's rainy, if it's sunny in the morning, or if it's very cold, then we run the risk of damaging the mortar before it's had time to work properly. So in summary, execution of masonry, as far as the Eurocode perspective is concerned, it should evolve over time. It should incorporate best practice, and ultimately that is what it is. It is a document that shows best practice, but it should focus on outcomes. And what I would suggest is that going forward, we need to be outcome driven as opposed to prescriptive in terms of the process of achieving those outcomes. It should reflect the national or the local styles of masonry construction, because that's what gives masonry the beauty behind it. I can compare masonry from the Netherlands with masonry from the UK, with masonry from Spain or Portugal. And they all have their subtle intrinsic differences that make them unique to a regional context, but also the attractiveness and the sort of the variation that is so attractive to an architect. But the last point I would like to make is that it is all about three key elements. It is knowledge, so it's the passing on of knowledge from us, the experts in the materials phase, the material sphere, to those who are experts in the construction sphere. It's the skills required to execute high precision, high quality construction. And finally, it's the behaviors behind how we communicate, how we translate, how we see those different construction projects going forward. So I'd like to thank you for your attention, and I'll hand over.
Okay, thank you very much, Andy, for a very clear and a very interesting point of view of the global issues we have to take into account at this quality and execution control. And we don't go directly into discussion. We will have a discussion at the end. So there will be plenty of questions, at least from my side. I have a couple of them already. I will hand the floor now to Franz so that you can also bring your presentation in. You can share your screen and start, please. Thank you.
So I hope you can see the full screen now.
Yes.
Could you confirm? Yeah, thank you. So I'm very happy to join this roundtable and to be part of it. And I hope we will have interesting discussions afterwards, after the presentations. I think it should be like that, as the topics are rather interesting, and we put a lot of work on the development of the European standards, especially on EC6. I'm part and even leader of the working group which handles EN 1996 Part 2, which deals a lot with execution and execution quality. I just take one aspect. Andy touched that already a bit and showed very nice photos, and I will put your attendance more to the content of the standard directly, and the possibilities which you could, how the national annexes could be improved in terms of that point. Especially the point of what weathering impacts and could influence the execution of the masonry, and what exposures could influence the finished masonry quality for that. So to avoid problems which have been shown already on photos by Andy. Okay. So just to give you an idea what will be the points, what I will talk about, I will show you some protective procedures during the execution of masonry. One point, which is, Andy mentioned that already, of course, it's a difference in which region you erect masonry. You have very different conditions. Winter conditions are not a topic in every country, but in many. And so it's a very important topic to find a good solution for that. We have exposure to wetting, and we have related protection measures. against this wetting and exposure in general, not only in terms of rain, but also in terms of frost, of course. And I want, at the end, I want to show you some additional possibilities how to find suitable, for example, tutoring rendering systems, which can help to protect against rain and frost. So to go directly into the standard, that's a text coming from the latest draft of EN 1996 Part 2, so from the 2020 draft. There is one chapter, protection against rain. It refers first on the completed masonry, that it should be protected from rain falling directly onto the construction. That's clear, especially in the phase when the mortar joints did not hardened completely up to that time. And of course, when you have jointing, the joints shouldn't be washed by driving rain in that phase, so you have to protect that. For the completed masonry, sometimes there are additional measures like a downpipe, a provisional downpipe, which will be or shall be installed. And of course, there it's important that you do that directly after you finish the masonry works, and there are not long time periods in between, which could damage the masonry already by, for example, wetting. If you have heavy rain, it's clear that you should stop the bricklaying and waiting for better weather periods. And of course, this is also true for the freshly pointed masonry. Then you should protect the points, the pointing works, and for example, by covering with special foils or whatever, just to protect the pointing. In terms of winter conditions, here there is another chapter from the standard, even the next one, so 563, protection against freeze and thaw cycling. Of course, you should avoid damaging, especially a freshly completed masonry and pointings. You should protect it against freeze and thaw cycles. And you should not use frozen materials for bricklaying works. That both messages are very simple, of course, and very general. So I give you some examples from the German National Annex, which is giving some additional information about that topic. So, for example, there is the message you should, in case the place where you do the bricklaying under such conditions, to protect your working measures and to protect the masonry against this winter impact. You are not allowed to use anti-freezing agents, which is not the case all over Europe. So there are many or several countries, for example, the Scandinavian countries, allow that to use anti-freezing agents. The same, more or less, which is in the general phrase already, you should protect freshly erected masonry by covering, for example. Another point about not allowance of methods is you are not allowed to defrosting salts, to do defrosting by salts. And which should be also clear, if there are parts of the masonry which have been damaged by frost, you have to remove them. In addition, for example, the producers give also hints and ideas what to do, or sometimes even clear messages how to do that. For example, use suitable mortars under winter conditions. There are, for some producers, provide special mortars for that, which are able to develop the properties also under winter conditions and under frost conditions. for Scandinavia, for example, there are special mortars which can be used even to -5 and -10, but nevertheless, you have to keep in mind that you should not use frozen materials, that's sometimes the problem. You have a good mortar, but if you use frozen materials, that's of course not helpful then to reach good quality. The standard also contains a table of classification of micro conditions of exposure of completed masonry. I don't want to go into this longer text too much, but just to give you an idea, I concentrated on the topic wetting and frost conditions. There are some other classifications in the table. So MX1, that's a clear message about you have dry environment. That's the case for the interior of buildings, but also for masonry which is covered by renderings, for example, and having not the combination with heavy rain. The next one is then the situation that the exposure is it covers also the heavy rain, but not in combination with frost or aggressive chemicals. And the classes in MX3 that covers then heavy rain plus free and thaw cycling. The standard also gives in the part in the Annex B an idea, at least that's an informative part. So we have to see what will be the national definitions regarding that table. But at least this table B1 gives you an idea of what building materials you can use under what conditions. As I mentioned, it's informative. So of course, that will be also to the transfer will be also related to the experiences in the different countries. And so you have to see what will be the national requirements regarding that topic. What is interesting and what is really helpful, we had a similar part already in the last version of the standard, that you see also drawings with describing the micro conditions of exposure. So not only related or not only given the general message about the exposure, but also showing, okay, when I have that and that detail, that and that part of the building, I have that and that impact, like you have a coping with overhang or without overhang, different solutions which are shown here in the different details. And you have on the bottom a rating for the exposure of wetting. So that's, in my eyes, rather helpful to have this description and this drawing. Of course, it's general and it's just giving a message, a general message, but in my eyes, very helpful for the engineer to check the impact. That's then transferred also to a building. So you have the same rating at the bottom, but of course, and you have partly the same details, but you see the whole building and you see the difference, for example, for the eaves, number 1 and number 6, if you have a flush eave or an overhanging eave. So there is, of course, a difference in terms of the impact of wetting on a building and of construction part of the buildings. And in my eyes, that's shown here nicely so that you already have a kind of rating, a general rating. There is a reference in the standard according to that, giving some qualitative ideas. So of course, the conditions have to be respected for the design. You have to use appropriate building materials. For example, when you use it without rendering, you should use the right materials, which are, when you use it in a region where you have frost, that there are frost resistance and points like that. If you have very high, for example, this 436 moisture penetration through external walls, there you can see, of course, you have to use a suitable rendering, or ventilated cladding, or other solutions which can handle that topic. That's qualitative, of course, but that's the relation also to these tables I showed before. Another point is, I just want to as a final point, want to mention the possibilities or additional information given from the manufacturers. For example, the association for building materials, for rendering systems, also for the building material itself, like brick or AAC, calcium silicate. They give you messages about how to do protective measures for the completed masonry. One point is to use suitable rendering systems. So there is a general information about that coming from the associations in the different countries. But we, as a producer of building materials and also producer of mortars, we made our own guideline and defined a method how to check the suitability. The method is like that we erect whole walls with an opening in it. We expose that to special climatic cycles, which take around 4 weeks, similar to that what you do, for example, for ETIC. We determine afterwards, so we put high temperatures up to 70 degrees on it. We cool it down by rain. We check afterwards the bond performance of the render and between the render and the substrate. We check the moisture distribution in the construction. We check all the material properties of the rendering mortars, which are part of the test. And if it's suitable and fulfills everything what we defined, then we give a recommendation for such suitable renders. So that can be also helpful to check the data, of course, which are provided by the producers. They have a lot of experience and they can give a lot of information of the right combination of materials. I hope that gave a bit of an overview about the content of EN 1996 Part 2, and perhaps also a small hint about what could be helpful to, which information could be helpful to be provided in the national annexes. I thank you for your attention. I'm looking forward to discussing the topics with you, and of course also looking forward to hear Dr. Meyer in the next presentation and getting some information about especially about thickness and quality of mortar joints. Thank you very much.
Okay, thank you very much, Franz, for a very interesting presentation and a very detailed, which, by the way, is one of the really interesting points here in this discussion, is to go into the details, because that's where many things are solved. It's in the details, and this fact of the microclimatic conditions was really, really interesting. So Udo Meyer has started. You are a very well-behaved presenter. Thank you, Udo, because you started immediately on what needed to be done. So I would hand you the floor, and I wish you a great presentation. Thank you. Oh, you have to unmute yourself. Thanks.
So once again, thank you, Miguel. Good morning, everybody. I will focus on a very special point: execution and quality control of clay unit masonry with thin layer mortar. First of all, we have to define thin layer mortar. Then we have to look at the execution on requirements for thin layer mortars. Finally, on quality control and possible future developments. So in EN 1996 Part 1.1, thin layer masonry mortar is defined as a designed masonry mortar with a maximum aggregate size, and in the further paragraphs, the code says that it is related to a joint thickness between 0.5 and 3 millimeters, and it is of higher interest if this range is a requirement or a strong recommendation, because when we're talking about mortar joints in general, we are saying, so it's round about 12 millimeters, and nobody cares if we are talking about 9 or 15 millimeters. So here we are in a range of tenths of a millimeter, and we have a rather defined range, and we are in danger to miss either the lower or the higher boundary and face the consequences related to that. So for the special case of clay units, you know that they are fired before being delivered, and after the firing, these clay units for thin layer masonry are grinded with specially developed grinding machines. One photo here with 2 consecutive grinding steps for these units that are running here in a row. So in that special case of grinded units, the unit tolerances are much smaller than 1.0 millimeters, and in one batch often even smaller than 0.2 millimeters. So this is a very, very precise shape of the unit. Coming to the importance of thin layer masonry, especially in Germany, we have first technical approvals in the early 1980s, and today the market share in monolithic external clay unit masonry is well higher than 90%. So it is more or less the most important way of construction in Germany for clay unit masonry. And I believe that the values for AAC and calcium silicate masonry in Germany are more or less comparable. So about execution, state of the art nowadays is a fully covered bed joint for the external thermal insulating masonry walls. So the mortar is applied with special tools to cover the full bed joint. There was a development of application techniques starting in the 1980s with dipping the units into the mortar and putting these units on top of each other. Then some types of rolling devices were developed and applied, and I say since more or less 20 years, the application of a fully covering mortar layer with special tools is more or less standard for external masonry especially. When we are talking about the masonry mortar for the thin layer joints, we have to prepare this mortar very carefully. We do observe precisely the defined water content to get a mortar that is suitable for this application. And we also highly recommend to use special mixing tools and to observe the mixing times exactly to get a good quality product for the execution. On top of that, an adequate first layer is absolutely necessary, because the first row of units has to be absolutely exactly precise leveled, and the first layer has to provide a sufficient strength for the masonry on top. You do not know if this first layer is a first layer in a 6-story building or a 1-story building. So mortar strength is defined in Eurocode 6 as mortar strength M10 for this base layer, and for the leveling of this first layer, special tools are extremely helpful, not to say absolutely necessary. So once this is done, mortar is mixed, first layer is applied, bricklaying is really fast, but you shall not forget that the tools that are necessary for applying the mortar have to be thoroughly cleaned afterwards. So this takes some time in the end. And requirements concerning the mortar joint. The main task of the mortar joint is leveling the unit tolerances to avoid stress peaks, to provide a sufficient bond strength between the units, and to not to increase the thermal transmission through the walls. So these points have to be addressed by the thin layer mortar. So a bed joint shall be fully filled with mortar to avoid stress peaks and to provide a good bond. I think this is no question. This might be not totally easy for vertically perforated units. You do need a special mortar formulation to avoid the mortar applied on the bed face to dip into the holes. And you should, or you must at least cover all webs and shells available with the thin layer mortar. Leveling should be achieved for grounded units if the thickness is equal or greater than 0.5 millimeters. And this is the case for grounded units. For other precision units that are prepared in another way, maybe by cutting or by pressing, the joint thickness may be greater to provide a the avoidance of stress peaks in the masonry. We did a hell lot of tests on thin layer masonry in the last 40 years, and we measured joint thicknesses during these tests, and we can say that with joint thicknesses that are greater or equal than 0.5 millimeters, we are able to meet or even to exceed the masonry design values in Eurocode 6 for compression and shear. And this even if the requirements for bond strength tested with the EN 1052 part 3 tests are not met in all cases. So coming to quality control, my idea is that a fresh mortar thickness of ±2 millimeters, which can be defined by a gap in the tool for the application, ensures a sufficient joint thickness and is highly recommended by our producers. Nevertheless, the final joint thicknesses in these cases, application of 2 millimeters, can be as little as 0.5 millimeters for vertically perforated bricks, because mortar may evade into the unit holes. So measuring the joint thickness, quality control is easy on one hand and very difficult on the other hand at a time, because no measurement rules are defined and anybody can measure anything, and this gives a significant potential for discussions on site, and as we saw it in Germany in the last years, also in court. So the definition of an appropriate and easy to handle quality criterion is an important task. Coming to the conclusions, masonry with thin layer mortar is the prevailing type of construction in Germany for load-bearing walls, except veneer walls. Construction techniques are well established, masonry properties are well documented, and nevertheless, some requirements in EN 1996 may be too strict. Maybe the joint thickness, or even too conservative concerning the bond strength determined with the test setup according to EN 1052 part 3. There is little guidance on quality control for measurement. This is in some cases a problem, and more research in these fields is very much appreciated. What will be the future? Probably thin layer masonry is a very fast way of construction. Cleaning of the application tools is necessary and time consuming at the end of the day, and so people are thinking about improvements. Some developments, not saying improvements, are shown on this last slide. People are using prefabricated mortar pads that are wetted and are bonding the units together. People are starting to use foams, and I'm rather curious what ideas might be coming up in the future. So thank you for your attention, and I'm eager to go into the discussion.
Okay, thank you very much, Udo. Yes, you stopped sharing your screen. So we do now have roughly half an hour for discussion, which is a very nice extended period of time so that we can go deeper in some aspects. These were 3 very interesting presentations that were pretty much complementary, and this was a fruit of coordination also between the presenters. So I also acknowledge this and thank you for that. It is now my job to try to coordinate here some sort of structured discussion, and we do have a couple of questions placed online, and we could address them in a sequential manner, of course. And I would start with one aspect which relates to the structuring, and particularly to Andy, the first presenter, the structuring of the discussion of this revision to the Eurocode. So where are we now, even for the people watching that are not so into the process of this revision? So what are the timelines and the discussion periods that are being hosted with the national committees, national MEYER committees, and to what extent is this being involving the industry in general, so that everyday appliers, the industry not involved in the committees, can somewhat be informed and even contribute in some way? Is this something you could address a little bit on that and elaborate?
Yes, I will do. I would struggle to give you the direct timelines. I'm not involved myself in Eurocode 6 committees, although we do. Obviously TC 125 have close connections, obviously being the masonry standards body. But in terms of the timelines, essentially we're the this revision is somewhat overdue. The original version of Eurocode 6, or the last revision of Eurocode 6, was circa 2011, if I remember rightly. So we're in a 10-year sort of rolling program. Most product standards would be on a 5-year program. So that gives you, an indication that whilst there may be evolutionary processes that are taking place within the production and the standards that relate to the product being used in the construction process, that the guidance with regards to the construction process itself tends to lag behind that. So, but in terms of the general concept of how they evolve and how, you're entirely correct in saying that essentially it's a cascade process where there is a revision process called, which is cascaded out of the European committees, the SEN committees that look after the Eurocodes. They go then cascade down to the national committees, and the national committees, in theory, should be then communicating with their representative trade organisations within those sectors. So in the UK, we would naturally be talking to building control officers, we'll be talking to the National House Builders Council and other interested parties, BRE. So there's a very broad approach to it, and in some respects, one of the issues that I would say that we suffer from in respect, and particularly within the construction sector, it is such a broad church of many individuals, many different companies, many parties that have individual interests in that. It's very difficult to actually draw them all together in this cyclical nature. So it's very difficult to entice out of them exactly what it is that they would like to see being modified within the guidance. So it's very much left then to what is relatively a small community within the standardization process, who then represent each member state and therefore obviously the national annexes reflect that, but also the information that comes from a member state's mirror group is fed up to that of the SEN committee. So sometimes things can drop out of it. So it is unfortunately one of the failings of the processes that we have. But on the whole, I think we do capture the majority. But it is not as fleet of foot or as nimble as I think many people, particularly those that are in the areas of innovation, would like to see. There is a time lag, unfortunately, but it's one of the consequences of us doing this process probably on a 10-year cycle rather than on a shorter cycle.
Okay. Thank you. We do have information on the YouTube interaction that the last draft is on 31st April and then hand over to SC6. So we are really nearing the end. Oh, okay. So thank you for the answer. It's indeed it's not only in this field. I'm also particularly involved, for example, in task groups for CN, for BIM, and for reinforced concrete, and this is a really slow process. It's really hard to harvest the opinions, and in many cases it's really hard to harvest consensus to get things, and then you can, on a very small discussion, you can delay the process by a couple of years, but it's definitely necessary, and because in the end it will be a norm and it needs to be respected. Okay, so thank you for that. I would now just go to go in sequence and address each one of the speakers in order. There's a question by Ulrike Peter to Franz, asking whether you will promote system testing in EN 1996 or not.
I think of course we do such tests, but we do it in a special context. If you combine, for example, masonry with rendering systems, and you want to give, as a producer, we give recommendations, or we have guidelines coming from associations and putting together the relevant information so that they directly can be used by the customer or by the engineers or who is involved in the process. but I think that will stay on the level of the producers and of the associations. It's different in terms of, for example, giving information about the properties of masonry, like compressive strength of masonry, flexural strength of masonry, where there is a clear standard about it, like EN 1051, that series. Part 1 is about compressive strength, part 2 is about flexural strength of masonry. And you can relate on that, you can do the tests, and you can bring that into the standardization work and provide data coming from that. So it's difficult to give a real clear rating for the system quality of combination of render, mortar, and masonry. But in terms of properties, yes. I hope that gives an answer to the question, or that was meant with the question.
Yeah, because I just have a sort of a comment. I'm not sure if I seek an answer with this, Franz, but maybe you comment as well. Because the masonry itself is a complex system. It's not like what you have in a brick, which can have a declaration of performance, CE marking, and this is really straightforward. You have these items to check, and bricks will be, even though they are different, obviously, and they are very different, but they can be standardized to a bigger extent. And precisely as it was being said before, different construction, different countries have very different ways of building, and standardizing this would be just a nightmare. So this is also my perception there. So in the end, it's really a little bit unsatisfactory that we do not get really a standard, but it's not that this is a product that can be standardized to that extent. And that would be just my interpretation, I guess, agreeing with that.
So that's what I also wanted to transport with the presentation, that of course on the European level, you have at least a good guideline, you have boundary conditions, and then you transport it to the regions. And of course, sometimes you even have to go to getting communication with the producer of the producers of the building materials, and to find good combinations of that.
Yeah.
Okay.
Thank you.
Yeah.
Thank you. Very clear. So then for Udo, we do have a question here that was raised online by Cliff Fudge. And he says, do you think that it would be useful for all if all national annexes were published in a single document, and that would be helpful for each country to learn from each other? And I'll just advance one thing that has also been mentioned in the YouTube conversation. Even though I agree very much with this, and I think it's really interesting, we have the copyright issues, of course, because these are paid documents from CN and from the national activities. So I don't know to what extent we could do an adaptation and do a guideline document, but it could not be a direct translation of the actual national annexes, I would believe. But I'm just trying to mess up with the answer. I'm sorry for this. So go ahead, Udo. You know much more than me, I'm sure.
It is an interesting idea. Having learned about the contents of national annexes as project team leader for Eurocode 6 part 1.2, I'm afraid that putting all these national annexes together would not be very helpful in the end, because 80% of the national annexes will say, okay, let's take what is in the original document, and the other 20% are saying turn right, and or 10% are turning right, 10% are turning left. So in the end, you are still you have to decide on your own what will be the right thing. So this is at least the experience we had in the fire part of the Eurocodes. Some values were increased, some values were decreased. Proof for that was given in most cases only in a way we have experienced for the last 6 years that this is necessary, or we have the experience that this works. In many cases, not really supported by test evidence, but masonry is a very traditional material, so yeah, it is interesting what we saw when collecting all these things, and there is a database at JRC having all these national annexes collected, but in the end it will not be very helpful. Maybe the system changes, and when we get the next national annexes in whatever 2027, 28, and we get the next collection, maybe this will be more helpful, but in the end it will be more helpful for our colleagues maybe working on the third generation of Eurocode, and for them this database already exists, so maybe we can benefit from this in the future.
But nevertheless, I think it would be a good thing to bring together the experiences and the knowledge from all over Europe, and trying to respect that also for the evolution of the standards, of course. But just to confirm that the last point.
Yeah. No, we did indeed at the University of Minho. We did carry together with the European Lime Association very recently an analysis of the mixing for mortars according to the current national annexes of Eurocode, and it was really interesting to see that despite there's a very wide range of variation in the classes of strength and how you are getting to the mixture proportions, and even in different strategies of weighting and making volume, whatever. In the end, there are some trends we can actually capture, and there are some ways of doing things that are sort of pan-European to a certain degree. So in the end, bringing this to the attention of the industry is an interesting thing. But from my perspective, and this is just a mere opinion, it would be some sort of review document. It could not be just copying the national annexes, because you need to crunch the information. There needs to be some degree of compatibility and systematic review. But I think this is really an interesting thing, and at least speaking from the side of the academics, we will be happy to work on that in the future. Okay, but yeah, okay. Thank you for that and for the insight. So going back to a little bit of more further discussion, I am selecting here where to go next. Yeah, I would go to Andy again with just a general question. And I'm really sorry, I'm a person with a lot of reinforced concrete background. So when I make here sort of a comparison, I see that we have EN 13670 for execution and quality control of reinforced concrete structures, and which gives us pretty much a very well detailed sequence of operations for all the process of mixing, all the process of curing, and different types of elements. Is this the same direction we are going also in masonry, or is this too, there are too many worlds apart in the several types of masonry you can build, and this is not something we can code to that degree of extent of detail? Sorry for the provocative question. I think this is the purpose here as well.
Yes, yes. It is an interesting one. As I say, yes, this is where I have multiple hats on, as well as my allegiances to companies and standardization and whatever. Those of you that do know me, my PhD was in concrete. But I've spent most of my career actually in clay masonry. So yeah, what I would say is that I think the evolutionary, or the evolution of the different aspects. So for example, reinforced concrete, you are dealing with, on the face of it, a relatively small portfolio of materials. So you're dealing with the structural reinforcement, so the steels and the other materials that are used, and you're dealing with formulations of concrete that are appropriate to the environments that are being used in. With masonry, it is slightly different. So if you think just in the context of the masonry units, we have 6 different types of masonry units that we call upon. So we've got the clay brick, we've got the calcium silicate, the aircrete, the AAC products, the normal density or dense aggregate concrete blocks, manufactured stone, and natural stone. And therefore, to try and essentially pull that together in a single conceptual model, as it were, which is essentially, you know, where the guidance is trying to take you, I think is probably too difficult. There are too many variables there that are not really controllable, where you would take something like at let's say extreme ends of the selection criteria. You wouldn't use the same model, for example, if you were using clay brick and aircrete, AAC. So I think in that context, I think whilst it would be useful because it would simplify matters, I think the complexity of masonry, and bearing in mind that masonry, as far as TC125 concerned, masonry also includes the mortars and the renders, but it also includes the steelwork, so the bed force reinforcement, the wall ties, and other elements such as that. So there's a lot of diversity in materials there, and I think to come up with a single conceptual model that I think is very much applicable when you're dealing with reinforced concrete would be very difficult to find something that was ubiquitous across all of those different materials.
Okay, thank you. That was my perception as well. Just wanted to also raise it. Yeah, thank you for that. And also, there was one thing from Franz's presentation that was ringing my mind constantly when you were speaking about the environmental exposure conditions. And this is sort of a cliche question, but I will make it anyway. We are enduring climate changes, and in many situations in our industry, we are starting to look at what are the next generation of concerns we are having. And so the question is just whether this has been considered to any extent that there are some variations in the climatic standards that we are getting in each country. Is this already an issue that is being addressed to any extent? Is this influencing to any extent what the work you are doing, or not yet?
Not really at the moment, to be honest. So we, of course, we have a look at that, but there are no special rules which have been influenced by that and created for such situations. We know solutions, or I know that for example in the US you have special requirements coming or for regions where you have hurricanes, for example. You have special impact tests, like when you have from the wooden construction parts of it are thrown against walls, and you have to check if that can put heavy harm to the walls or even destroy it, and being a safety, you have safety concerns about that. So there are already such rules available in different regions on this planet, but we, up to now, it was, I think that will be for the next generation a big topic, and perhaps even defining some special rules for the national levels. But at the moment, it's not really was not really part of the discussion for this actual versions.
Okay, thank you. I would say that this is mostly probably we are encountering not the extreme events by themselves, but mostly that our average temperatures could be changing, our thermal amplitudes could be changing, and this could be in different regions of Europe causing impact, and maybe we shift rules that were formerly in a certain region and it's going to another, and even the differences between summer and winter are accentuating in many extents. So it's not about global warming. Many times we have even much colder situations. So yeah, that's it. But I think this is a process that is like the frog in the pan. It will be progressive, and at some point there will be a burst. Yeah. Okay, thank you.
You're right.
So on Hudo, I have a special question also regarding the dipping of the units. When you are dipping them, and you presented even a slide where there was some sort of standardization of this process, what we realize even in our laboratory works, where we are trying to compare different behaviors of different masonry units together with different mortar compositions, we realized that we were being probably too careful in dipping a very long time and very carefully the brick, and controlling well the moisture of the brick. And many times this is not taken in the industry, and the differences in behavior end up being wider when it happens in the industry. So my question is precisely, to what extent this process of dipping is not being respected in your perception in the industry in general? I'm not even talking about the new generation, even in the previous generation. How is the industry not doing the correct work? And then we have moisture migrations that were not expected. And how can we fight that? Sorry for the general question.
I think we can divide the question in two parts. First part, for external walls, dipping is not recommended. There is a clear recommendation saying use these tools, apply a sufficient thickness of mortar on the wall to get in best practice a full cover of the joint, to avoid all problems that might be related to something we call in Germany socket typhoon, where we have air coming from the outside out of the sockets inside, and this can be avoided to a significant extent by using these or achieving these full mortar covers. So for external walls, dipping is not state of the art. We are trying to convince the workers on site to use these tools also for internal walls, but this is a rather difficult task. So for internal walls, dipping is still a technique that is applied, although if you're talking to contractors, they are saying, no, never, we are not doing something like this. And if you're turning around, people start getting the large buckets and trying to do this again, because it's really fast and it works because of the high exactness of the units. So for internal walls, dipping is a topic, and we are at this time doing a test series trying to see the influences of more or less even poor dipping under laboratory conditions on the masonry properties, to define a lower bound level and to get an information what in our experience, in our reception is still happening on the sites, even if the standards are saying, maybe saying something else. So in the end, if you apply, or if you come to the point where dipping is carried out according to, let's say, the rules, we do have a lot of technical approvals in Germany where dipping is still a way of constructing. And these approvals say if you're dipping the unit 5 millimeters into the mortar and all the webs and shells are in any way covered with mortar, this is a way of doing a construction conforming to this technical approval. And if you follow this and you have the units with the exactnesses available by grinding nowadays. I'm rather sure that you will get a masonry that is comparable to the physical or mechanical properties that are defined in the standards.
Okay, thank you. Yeah, this is indeed an important matter as well. Okay.
So, nevertheless, we do have experiences from the 1990s where we realized that grinding is a very important issue when you are trying to do masonry, construct masonry with dipping. If the grinding is not exact enough, you can easily get a factor of 2 in mechanical properties. Because the layer might not be thick enough to level all the irregularities, and you get some stress peaks, and this might happen, but for let's say nowadays, and the machinery that is available nowadays, I'm rather convinced that you get more or less similar mechanical properties also with dipping, although saying it again, it is absolutely not recommended by the industry.
Okay, I was going also at the pre-wetting by itself of the brick or the unit to avoid soaking moisture from the mortar.
It really depends on the type of unit that you are working with. Maybe pre-wetting has a positive effect, but I think every unit has different properties. There is for every type of unit, you have a more or less optimum of moisture content, and if you are thinking about thermal properties, you have to realize if you put water into a unit, it changes the thermal properties, and 1% of moisture content changes the thermal properties in a range of 10%. So you have to be rather careful with that as long as you are in external masonry. So for internal masonry, okay, you have to put on your heating and you will cope with that. But for external masonry, it may have an influence. So too much pre-wetting is not really recommended.
Okay. Thank you. So we can go to another matter. We are approaching the end of the session, so I don't want to bring this too much bigger than what is expected in the program. But I cannot resist to make a couple of questions, and I'll just put this to the entire panel. And these couple of questions or comments are: first one regarding the robotization, and I'll just express an opinion of mine. Robotization, in my opinion, is a very interesting trend, but I completely agree with what Andrew said. It's not yet there, so we are not actually seeing this everywhere, and there are some very exceptional examples sort of in laboratory or indoors. And but it is my conviction, and this is my comment, that the extent of requirements we put to a robot to do a masonry, they should be the same that we put to the human, because the robot will be able to do the same or even better. Okay, so if we set requirements, they are to go towards better, not even to match, it's to go beyond. But this will go on the direction of going into artificial intelligence and things like that. So current state of robots would never satisfy that. So this is my first provocation. And the second provocation is about circularity in materials and in the construction. To what extent is this affecting already, for example, the use of recycled aggregates in the mortar or some recycling in the units themselves? Is this affecting already anything going on in this context in the normalization? And these are my provocations. So the floor is open for final allegations. We can go in the sequence of Andrew and then Franz and Udo. Thank you, Andrew. Now.
The subject of alternative materials, recovery of materials and reuse of them is very close to my heart. It's something that I've written on and presented on for the last 20 years or so. And coming from the brick industry, it's something that's been happening traditionally, certainly in the UK and in parts of lowland Europe. It's certainly been happening for over 100, 150 years. Routinely, materials would be recovered and reused within the brick manufacturing site. So I think as far as that's concerned, yes, I fully foursquare behind it. We should be recovering, we should be maximizing use of all of our materials that are going into the second, third, fourth generation of use. So I'm a big advocate of looking at that. How they will be adapted, accommodated for within the standards is, I think if we look back, if we turn the clock back 15 years, where the concrete sector was saying, on no way shall we be putting recycled materials in terms of aggregate, crushed concrete aggregate into our things. So if they were specifically excluded from concrete standards. And then the term sustainability became very dominant and is now a very laudable driver for it. So I think, yes, standards have changed. We need to be able to accommodate for it. But we need to bear in mind that it cannot really be second best. We have to use them judiciously, we have to use them appropriately, but we cannot, by using something that may look to be sustainable, then further down the line cause a bigger problem. So I'm thinking along the lines of, we can't really advocate using of industrial wastes that subsequently will then lead to things like ground and water pollution from leachates. But we have standards to take those into account already and to test for that. So we're starting to understand. But again, this is part of the process. It is an evolutionary process. Very rarely within construction do we ever find revolutionary changes. This is all evolutionary. And I think the more understanding we have of the use of these recycled materials within primary construction products, then the better contribution we're making to global sustainability, full stop.
Thank you. And Franz, any opinions?
Yeah, there were, of course, in the past, perhaps we had very much a view on the properties in terms of energy efficiency. Of course, heat insulation, big topic, saving energy and workability of the blocks. Perhaps that were more or less the main aspects. Now, of course, we already have, we look very much on the ingredients. We have the topic about, for example, for concrete, you use cement. What is with cement? Are there other possibilities to use to create concrete or also to produce mortars without using that, or with adapted cement produced in another way? We try to adapt our recipes to produce AAC with different additions. But meanwhile, we of course have a wider look, and we also look what is called sustainability. The word is used very often, and of course sometimes people are tired of hearing that. But in the end, it's a clear description. We have to keep everything in mind and to try to develop in different ranges of questions and of aspects. We even have now, as a producer, a recycling product using recycled AAC for producing a calcium silicate block and things like that. So we try to work on all these fields and bring it together. And that's the aim for the future, of course, to find very good solutions, respecting all the topics and needs what we have to have a positive influence on the environment. In very short words.
Okay, thank you for the perspective. And Udo, now handing over to you. Thanks.
Yeah, I think circular economy will be one of the top topics in the next 10 years. And we already started working on that some time ago, and we are doing a lot of projects trying to evaluate reuse, recycling, etc. of clay products, of masonry products containing clay. The recycling process is rather difficult because many walls are not only consisting of clay and masonry mortar, but there's also render. In many cases, render with a high content of sulfate, and you have to address that. And there will be a lot of efforts in our industry in the future. We already started some projects on that, and it will be a very important topic for sure.
Okay, yeah, indeed. Thank you. So for the sake of completing this within reasonable time, I would like to thank you all for your contributions. But of course, I have to hand over now the speech to Dr. Ulrike Peter. Ulrike, maybe you want to make some final comments and close the session and even address the other participants. Please go ahead. Thank you. Ulrike? Oh, your sound, please. You're still muted, Ulrike. You're still muted. Oh, now yes. Okay. Yeah.
We are still on the YouTube channel. So I would also like to take the opportunity to thank everybody for this very interesting session again. I'm very pleased about the quality overall of our presentations and discussions. And yes, I just can say thank you. And well, we will come back to you on the format and the date of the last conclusion session of this roundtable.
Okay. Thank you very much then. I think we can declare the session closed. Thank you all. Goodbye.
Bye-bye.